Hi there. Let's look at our next topic in our unit on the Earth's crust. We're going to look at properties and how we can identify minerals based on properties. And then we're going to end this lesson looking at different ways that minerals are mined and some pros and cons. It can be a little bit confusing when it comes to studying minerals, and so let's use another analogy. Last time you saw we talked about an egg. Today we want to talk about cookies. So I have chocolate chip cookies here on the slide, and the reason I have them is we might think of cookies as rocks. Now, cookies have ingredients or building blocks, so to speak. Ingredients for cookies are chocolate chips, and you notice all these chocolate chips are the same. Flour and sugar, all the sugar is the same, all the flour's the same. So these ingredients have the same properties. However, when you look at a cookie, it's going to have varying properties. Not all cookies have the same amount of chocolate. Some cookies have a little bit more flour than others. And so cookies are similar to rocks in that when you pick up a rock, it could have a whole bunch of different minerals in it in varying amounts. Whereas the ingredients we would call minerals. So minerals and their properties don't vary or don't change much, which makes us easy to identify minerals. So let's go on to talk about minerals. Minerals are the building blocks to make up rocks. And there are hundreds of different minerals, all with different properties. What I mean by that is, if I took a slab of calcite, which is right here, the properties of calcite are going to remain the same. So if you have 10 samples of calcite, they'll all have the same properties, same hardness, same shape, etc. However, if I take 10 samples of rock, each rock might have different properties depending on what's in it. So in general, rocks have varying properties and they come in three groups: igneous, sedimentary, and metamorphic, based on how they form. So what is a mineral? The definition for mineral is a naturally formed inorganic solid that has a definite crystalline structure and definite properties. And we use these characteristics or properties to help us identify minerals. We'll look at hardness, crystal shape, luster, color, streak, how they break apart, their density, and then a few special properties. So the crystalline shape of a mineral can help us act as a clue to its identification. And there are 6 basic groups of shapes that we usually look at. Next, luster is a second category. This describes how the light bounces or reflects off the surface. Usually we say it's a metallic luster if it's sparkly and shiny, or non-metallic. Non-metallic might be dull, glassy, waxy, or pearly. Color is another property, and some minerals have very characteristic colors. Others vary due to chemical impurities. The next property that we use to try and help us identify unknown minerals is something called the streak. We usually take a porcelain white streak plate, and what we do is we rub the mineral and we look at what kind of color the powder is left on the mineral. We call that the streak. Believe it or not, some minerals do not streak the same color on a porcelain plate like they look. The next property we might identify or use to identify minerals is how it splits. We call this the mineral cleavage. So if it splits in nice wafers, then we say it cleaves. However, when we try and split it apart, if it just crumbles, then we say that it's fracture. So minerals that unevenly break is called fracture. Minerals that kind of flake off in a regular pattern, we say it has cleavage. Probably one of the most definite properties of a mineral, almost like a fingerprint on a human, is the density of a mineral. All minerals have a specific density, and this is by far the most valuable property we could use to identify minerals. Another way to talk about density is specific gravity. There are a few other tests that aren't quite as helpful. We call these special characteristics. For example, the acid test. Lots of calcium carbonates react with acid and they'll fizz. And some minerals actually glow in the dark, or fluorescence is what we call it. This is pretty rare. And some minerals have a salty taste, but you should never taste minerals if you don't know what it is, because some can be harmful to us. Halite will taste salty. And a few minerals, lodestone being one of them, and many containing lots of iron, produce a magnetic field and are magnetic, like this lodestone. And finally, another really useful one, not as useful as density, but close, is how hard the mineral is. This is a picture of the hardest mineral. It's called diamond, and diamond is used often in many cutting tools because diamond is so hard. And so how we test the hardness of a mineral is its ability to scratch other minerals. And there's a scale that we're going to learn to use called Mohs scale, where we use arbitrary minerals on a scale of 1 to 10. So let's look at Mohs scale. 1 would be talc, 2 would be gypsum, and so on. So here's how it would work. If you had an unknown mineral, step 1, you scratch it against talc. If this unknown mineral leaves a mark or a scratch on talc, we keep going. Scratch it against gypsum. If the unknown mineral leaves a scratch on the gypsum, we know it's harder than a 2, and we keep going. Let's say eventually we scratch it with this, which is apatite, and the apatite leaves a scratch on your unknown mineral, then we would say it's about 4.5, or somewhere between 4 and 5 is its hardness. Sometimes we don't have a hardness kit with the prescribed minerals on it, and so sometimes we have to use everyday objects, like our fingernail is about a 2.2, a copper penny is about a 3.5, an iron nail about a 4.5, glass 5.5, steel file 6.5, and so we might have to use those everyday items to come up with the hardness. Here it is again, another version of Mohs hardness scale. Again, these ones don't vary. However, if we don't have these particular minerals, we might have to use everyday common items on Mohs hardness scale to help us determine how hard the mineral is. Here's another slide to describe luster. A sparkly mineral has a metallic luster, whereas one that doesn't shine or sparkle we say is non-metallic, and we might use words like glassy or dull for that. Here's the streak test I was talking about before. So there's the porcelain plate that we would use, and we scratch it, and whatever color the powder is left behind. This is the best test for us to identify the difference between iron pyrite, which is this substance, and real gold. Iron pyrite is fool's gold, and it will streak kind of a blackish color, whereas real gold will streak a normal color. Here's a formula that we use to find the density of a mineral, or the relative density. We take its weight in newtons in air, and we divide it by its weight in air minus its weight in water. And so you're going to practice using all these characteristics to find the identity of 5 unknown minerals in the lab. Let's talk about mining. What is mining? Mining is the extraction of ore or minerals from the ground, and ore is a natural material with a high concentration of valuable minerals in it. There are 2 main types of mines, surface mining and then subsurface. Surface mining is sometimes called open pit mining. Open pit. And subsurface, obviously you have to drill mine shafts to get below. Mineral deposits are on or near the surface of the earth or removed in surface mining. And there are three types: open pit, quarries, and then strip mining, where you remove the surface of the coal. Here's an example of an open pit type mine. As you can see, it makes a huge impact on the environment because you have to make roads for the mining trucks to get down, and so environmentally this is a really harsh way to get your ores or minerals out. Here's another one, as you can see. Subsurface mining is not as bad because you just drill below. Shafts and passageways are dug. And so here's an example of that, subsurface mining. And so the shafts are either horizontal or vertical. And so this is way more dangerous. Subsurface mining is way more dangerous. There can be issues in regards to oxygen levels and whether they're good or not. The mine can collapse. However, it is, as I said before, more environmentally friendly. Lots of times, once the mining company is done, because they destroy the habitat, reclamation is needed. Waste products can pollute, and when a mine is no longer being used, the land should be returned to its original state. Here's an example. This is the mine before in Quebec, and here's the mine after trying to reclaim the land. So we do need mines. Here are some products, for example, that we need from mines: salts, clays, zinc, petroleum, lead. So, it's not as easy economically just to say, let's ban all the mines. So it's kind of a delicate balance because we need mines for many things: houses, cars, toothpaste, plumbing, wires, and so on. Cell phones, without mines, we wouldn't have those. So if we can't grow it, it has to be mined. So that's an overview of this topic on minerals and mines.